Hello everyone. Today I want to talking about the CA analysis by CATIA program. Today's target is for about 2D element CA analysis practice. The modeling sketch is like this, and we first of all, to perform modeling before analysis, first enter the part design workbench and sketch the X, Y plane with the following shape and then apply constraints like this. Therefore, we should go to the part design workbench first, like this button, and we can, along with the X, Y plane, we go into the sketch workbench like this, and following as lecture document, we should made some sketch like this. Maybe some sketch should be checked first. The radius of this corner should be 150, and this value should be 100. Therefore, the magnification should be adjusted from this operation, and this should be also tangency alliance, and in addition also this should have aligned with the tangency like this, and this, and maybe the distance from this should be 5,000, 500, I think. Okay, in this time maybe something should be 400. From this one, between this one have 400. In addition, the profile should be made from this operation well, and 3-point arc making should be needed, and the profile should be accomplished in this operation, and this should have the alliance of tangency, as you know, and the radius of corner should be 50 millimeter in this case. Absolutely, the difference between this have 100 distance. In that time, everything is changed from white to green, and you should click mirror image, and from this one you can accomplish everything. We should check the distance from this to this. Should have 1,000. Okay, then if you finish it, then you should check the sketch analysis, and everything should be closed. 14 curves are closed. Then if you check it well, then please exit to the sketch workbench, and the next is to modeling a pad. When the sketch is complete, use the pad function to extrude 250 millimeter in both directions using the mirror extent option. The three-dimensional shower chair modeling is completed with the following shape. Therefore, we should click pad and 250 millimeter we should be given, and the more mirror extent should be also take, and the shower chair can be somewhat simplicated shower chair, I think. Oh, I should check something should be too thick. I should check the difference between this one and this one. 100, 100, 100, 100. Okay, that's all right. Then next time we should click mid surface in this time. Click the start button and select mechanical design, wireframe and surface design. Click the offset button on the surface toolbar. We should go to the wireframing surface design, and offset button should be placed in surface, or yeah, please click offset button, and in this time the offset surface definition dialog box have been appeared in the screen, and surface should be selected. The first one, 1, 2, 3, 4, 5, 6. The sequence is important. Therefore, in the surface, we should click first, second, or before making it, we should do before making offset, we should firstly join button first, and in this time we should join to click offset button first, and in this time in the surface, mouse button number 3 should be clicked, and create join should be selected in this time, and the join surface should be selected this sequence. 6 joined surface should be needed in this time, and please click OK. Then the upper part of the surface should be made like this. Then after this, we should give to the offset value to 50 millimeter in this time. Then if we click preview, then this offset value should be generated in this direction, like this. Maybe after conforming, please OK button, and a pad should be hidden in this time. Then only the mid surface can be seen like this. This is the method to made join offset surface. Offset is exactly mid point of the pad. Mid thickness of the pad can be generated in this time. After that, we should make give apply material property from material property button, and if the dialog box should be made, then there are too many fabric construction method, other painting, other things. However, we should select metal and aluminum should be selected in this time. However, the activation button not be shown in this dialog box. Therefore, in this time you should click part 1. Then the OK or apply material button can be activated in this time, and please click OK button. We should check if we click aluminum and double click aluminum and in the analysis button we can see the Young's modulus of aluminum should be 70 gigapascal and the Poisson ratio is 0.346. Density is 33% of the steel. Therefore, in case of steel, the density was 7,860 kilogram per meter cubic meter. However, in aluminum, just about 33% of the steel. Therefore, its value is as shown in this figure, 2,710 kilogram per square meter like this. And the summer expansion and yield cells should be 95 megapascal like this. Then you can find out about it, and we can see aluminum material is made in this case. You can find it, and after that material property should be applied. Therefore, we should select this one, shading with material. If you click shading with material, then some like aluminum color can be applied to this part design model. After that, we should go to the next step. First step is for set up pre-processing. In case of pre-processing running, the GSA workbench should be needed. GSA was the start generative structure analysis placed in analysis and simulation like this. Therefore, if you find it, then you should click this generative structure analysis workbench, and also you can see new analysis case dialog box. You can see like as the previous class, and you can select static. Almost every case in the structural analysis should be made by CATIA CA program should be selected only static. Over 90% was a static case like this, and you should select OK button in this time. Okay, then in the generative structure analysis workbench, a mesh is automatically defined for the shape, and the settings can be changed in the specification tree. When the tree is expanded, maybe you should expand this one by pushing the plus button, and we need to create 2D shell mesh. Or maybe, as shown in the figure, maybe in the finite node and element, if we click plus button, then tetrahedron mesh should be made like this. However, in this model, in this case, this is not a 3-dimensional shape. It is only 2-dimensional shape like this. We can call it shell element. Therefore, octahedron tetrahedron mesh is not 2D mesh. Therefore, we should make 2D mesh in this time. Therefore, by using mouse button number 3, we should delete it. We don't need a 3-dimensional element like this. Therefore, if that is deleted, then we should make a 2D shell mesh. and also proper in the property 3D property is not needed in this time, therefore it should be also deleted like this. If we deleted two tetra mesh elements and 3D properties, then shell mesh definition should be needed. Click Start on the menu bar and select Analysis and Simulation Advanced Meshing Tool. Start Analysis and Simulation. First one is Advanced Meshing Tools like this. And if you're ready to perform it, you should click this one by clicking it like this. Then meshing tool should be made in this case, and in the previous time beam mesher should be used in the previous time, as you remembered. However, in this time 2D mesh should be needed, therefore advanced surface mesh octahedron surface mesh should be clicked, because this is wireframe and surface. Therefore, we should click surface mesh like this, and you should click this one. And if you click this one, then the mesh global parameters can be shown in this figure. And in this time, surface mesh toolbar, and enter the mesh size of 50 millimeter. Mesh size should be changed from 15 to 50 millimeter in the dialog box, and select the quad only option. Quad only should be, there are many things, quad or triangle, complex quad can be used. However, we should click only quad only mesh in the dialog box button, and the red arrow that appears in the model indicates the upper direction of the shell element. Click the OK button. Please click OK button like this. Then this kind of things can be made, and mesh screen display according to view mode. Maybe we should let's display the mesh on the screen by practicing. Analysis can be performed without this process. But it is performed to learn the mesh display method. First, enter the GSA Workbench. Start analysis and simulation and generative structure analysis can be made, and node and element please mesh visualization should be selected. OK button. Then the 50, maybe you should check the distance between this 50 millimeter. I think between this node and this node should be 50 millimeter. You can find out, and you can check it. And if you click this to shading mode, however, if we click shading with material, then mesh should be hidden. And if we click wireframe, then only wireframe can be made in this shower chair like this. Therefore, we should check this one. And the view modes, as far the mesh is changed into various shapes like this. Next step is to give shell property thickness settings. To set the shell thickness, click 2D property on the model manager toolbar. in the model manager, you can find this one is a 2D property like this. Place it in model manager. Click it. If you click it, then 2D property dialog box should be shown in the screen like this, and make it appear as mouse button number 3. Hide show in links manager. If you click this one, if you click this one, should be hide, then the shell and the mesh can be displayed together, and because the shell display should not be needed, therefore you should click this one once again, and shell property may be should be given, therefore click shell and support for making shell property, we should show the link manager for surface, and we should give clicking it, and in the support we should click one surface. One face should be selected, and shell thickness should be given to 100 millimeter. Why you this is changed from 1 millimeter to 100 millimeter? Why you give to the shell thickness to 100 millimeter is that in the link manager type in the part design workbench, in the previous time we should check it, and the sketch should be given like this. Sketch thickness should be 100 millimeter like this. Therefore, the thickness should be given to 100 because of this reason, I think. Therefore, maybe the 2D property should be given to 100 millimeter like this. Then, if the 2D property should be set up, then maybe this is the expression of shell thickness like this. And next one is to set up a boundary conditions, maybe for about restraint. Boundary conditions and loads can be applied to surface, edges, and the point of the shape. Hide mesh and 2D property in the node. Node and element group. This is the node and element group, and hide it, and click user defined restraint. A model manager should be show, and in this time this is a shell thickness, and node and element group to apply boundary condition to the product shape. Hide the mesh and show only the shape, only the surface. Click user defined restraint on the restraint toolbar. This is the surface slider, and next third one is user defined restraint toolbar. First select and select the corners. This one. So in the support case, only this one, and this one should be selected for user defined restraint, and click the OK button. 1 2 3 1 2 3. This is X Y Z, X theta, Y theta, Z theta. Theta means the rotation. Therefore, please select it, and two edges like this. the axis system type should be selected to global like this. This is global fixing method, and please click OK button in this time. Okay, this is time to end in this class. Therefore, thank you for watching until now, and see you next time. I will continuously do the practice in the future time. Thank you for watching. Goodbye.